derivative of the function, put x equals 1, find the slope, what is the point. First 2 points, everybody should get this. Start the work. As I clean this board, almost I'm finishing now, fast. Take the derivative of fx and then plug in x equals 1, that will give you the slope of the tangent. Then use y2 minus y1 equals mx to x into x minus 1. Am I saying it right? I'm tired. I'm going to go home and sleep now. Okay, what I'm saying is, here it is. So you get 3, get y, fx equals e raised to 2x. Now, before I even go further, they say find the A question is, what is the equation of tangent at x equals 1? So we need to know y also. Let's put x equals, because if x is 1, y is question mark, because we want to know the x1, y1, the point. So that x1 goes here, so f of 1 e raised to e2. So this is your e raised to 2. So your point is 1 e square in the formula. Then you find to know the slope, take the derivative, which is stays the same, and the derivative of 2x is 2, and then plug in, but at what point you want is 1 here, so put 1 here, e raised to 2, so that's the slope. And then we are almost there, y minus y1 equals mx minus x1, just plug in y equals e square, that goes here, and at the most you can just add e square on both sides, this goes other side. No. Next question is asked, and you have a figure like this. Doesn't look good. Okay, this is your point. 1 is square. So we need to figure out what is this area. Now this area is below the curve. Fx is x square e raised to 2x from 0 to 1. So to find the area, the formula is a b fx dx to the x-axis. So we want to find this until the x-axis here. Okay. Okay. Now to find this, your b is integral from where to where? 0 to 1 of fx dx, which is e raised to 2x. Take the integral of this, which is 2x, but the derivative of that goes down from 0 to 1. Don't get this 2 into the calculation, take it outside. Just plug this and this. So you get half e raised to 2 minus e raised to 0. The final answer is e raised to 2 minus 1. But the next problem is a little confusing. Okay. The next question is asked, what is the volume of the region? Now this region is saying, this region, I think I did not do much of this, but still, there was no time, but still I'm trying to show something. If you get it, good. What's going on is, this is a region. It is we are trying to figure out a volume of a solid here. So there are two parts here. it's like 0 to 1, this is like moving this way. So I just want to show this goes like this. See? Okay, this way. And they want to know a three-dimensional figure where you have get a volume, but not in the circular form. They want us, if you read the part there, cross sections perpendicular. I just want you to, what is the meaning of cross sections perpendicular to the y-axis? So these are the cross section but they have to be the y-axis are squares. That's the most important thing here. So what does that mean? Is not a circle like this. This is not circle because if it was a circle, you will say, okay, it's like you get something like a cylinder there. This way, this is the radius, half of the distance. So there are two parts here. We want a square here. If it is a square, I'm going to divide this into two parts. One is, this is one, this is also one, and this is how you get a square, like this, a cuboid kind of thing. See, cuboid. So the volume of that cuboid will be 1, and then you need to know also what is the volume of the, like there are a lot of cuboid we have to draw like this, something like this. So the whole, it is moving around it like this. So there's a volume created, and the cross section are the squares. This is a cross. Each time there's a cross section. Each time there is a cross, which is a square, and then this distance, so there is a square like this. And what is the length? What is this distance we want to know? That distance is, this is 1. If you want to know, find this is 1, and this side is in terms of y. So you are given y equals, because what does this 1 means? Oh God, am I doing it right? So yes, if I want to know that distance, or this distance, or this distance, I have to first find from here to here, and then from here to here. The big green one is the 1, and the smaller one is, you have to see, you're given, this is like your y, that means e raised to 2x is your y, 2x is, in terms of log, I can write a ln of y, because it's like log of y to the base of e. If the base is e, just write ln of. Okay, and then divide. So your x is half. It means this part, each square is like your. So this part is the green. The green one, this small green is half ln of y. The big one is 1. So each square has length as 1 minus half ln of y. So the formula is all the small little squares or cuboids, thin width here, they are going adding together whole volume as it moves like that, like this, each one of them. So the formula is volume becomes equals, this bottom part is your 1, but the second one is from 1, starts with 1 and goes all the way to its square, and each square is this one, 1 minus half ln of y and dy, and you're done. This is confusing, but just trick is like this, remember that this each dot, this is like there's a moving, something moving to get a volume, like a round thing like this. Like, so initially it will become big, then become smaller, but you try to cut cross section with a square cross section, not a circular section. If it is circular section, then it will write pi r square in that. So then it will be half of this whole thing, like a 1 minus half ln of y divided by 2, and then you square and put a pi. So this will be pi outside, and that way divide by 2. He doesn't tell us to solve this, so you're done and you get your 3 points. And the problem number, this was 3. Problem number 2 was and it's going to be so 1 hour kind of a thing, but still I just want to show to you guys to get the whole thing, even it takes, if I have time I'll show you also 2013 explanation tomorrow, but today I just want to make sure you get this right. Oh, this one. I gave you the explanation there. I don't know whether that will stop or whatever it is. Second problem, a quick thing in shortcut I want to show is on your paper. First of all, you are given. Let's say there is a shop here. This is a shop. People entering. People going out, right? So people are entering, and this is there will be a lot of people in. Initially, there's nothing there, but as the time progresses, you see shoppers entering inside and shoppers leaving outside also. So at every time there would be some of them inside. So to make this problem easy, you need to use a calculator. First of all, in your calculator, before even you solve, please write this. Your y1 editor, put it as 0.5 t raised to 4 minus 16 t cube plus 144 t square, okay? Is that right? Then what I would do is, let's write the derivative of this. Now this is your s of t, right? So the shoppers, number of shoppers entering, number of shoppers entering. So, but if that, put it as y1, but if I take the derivative of this, call it as y2, the derivative, at what rate are they? At every hour, how many are entering in the, so 4 times this is 2t cube minus 48t square plus 288t. Then also I want you to enter y3 as shoppers. The rate of shoppers leaving is given to you. If you read the question, leaving is, it's shown in the C part, minus 80 plus 4400 minus 14t plus 55. So the first question, let's go one by one and get, why did I put this in the y1 editor, y2 editor, y3 editor is because you have to use calculator to get quick answers. Suppose I want to get the answer A. So A says, at what rate are the shoppers entering the store 3 hours after the start of this rate? That means the derivative. So what you do is, you can directly put t equals here as 3, 3, 3, get the answer. That's all it is. Or you could use this one and write it like this here. On your calculator mode, d by d box, and there is something like this. And then there's a box x equals n box. So what you can do is click here on your calculator, click alpha, then click on the trace, and then you will see there will be y1, y2, y3. Now since you want to do the derivative, so what do you do? Click on this one, or directly enter, because it shows you by default. Just enter. This will pop up. When this pops up, here put x, and this whole this, when you enter, this will come y1 here directly. See this? This y1 will come. Put this as x and put x equals 1. Right? No. What? At 3, I think. Sorry, 3. So when you do this, you get the answer as 486. Okay, make sure. That means at what rate the shoppers are entering. What does this mean is at 3 hours, the rate at which the shoppers entering is 486 person per hour. So the rate at which the shoppers are entering is 486 persons or shoppers per hour. So if you want, you can write that nice words also. Average rate at which shoppers are entering is, you already have it on your handout. So average rate or at which shoppers are entering the store in shoppers per hour is 486 at that moment. Now look at the next question, B part. Now this is one way of doing, or you could directly put here, you could say, okay, you could go to the second, first of all, second quit, get a blank screen, then click on, you could click math, then go click 8, and you see, you don't have to do directly click on, not the same thing, alpha, trace, enter, but go for y2. So not this, I'm sorry, you don't have to do this. So you can go for alpha, trace, and then there will be y1, y2. Click on this one. So when you click, you get y2, then open the parenthesis, plug in 3, close the parenthesis, you get the same answer. Now the question is, why did I do this one? Let's see the next step. C. Question is, find the value of okay. Now remember, this is called the rate function. It all like a velocity kind of thing. Remember, in the speed we call it velocity, but here people are entering. At what rate they are entering? So if you want to know, the answer of this is always how many number of shoppers. That's all it is. So this means we write this is the number of shoppers is S dash is here, right here. This is your S dash T. So we substitute directly S9. So this is same as, because there is an integral and derivative. So when you talk about integral or derivative, the cross are, this is like S of 9 minus S of 6. Check this out. Because this is like, if I take off this dash here, it means it is ds by dt, see? So this crosses out, but then you have to write from 9 minus 6. I don't know how to explain again, we did this long back, but I just want to show you, it is S9 minus S6. Let's write this average rate at which shoppers are entering the store in shoppers per hour between t equals 6 and t equals 9. So it's the change in, this is like, when you talk about displacement of a object or particle when you're driving down, it's like after 9 minutes and 6 minutes you see take the difference, and this 3 actually basically is nothing but 9 minus 6. So the time is 3, and well, maybe this is like a distance covered and this is like a distance covered. So when you take away, so it's like a velocity, or the same thing like this. It's the average value of the velocity function also, which is S9. So how do I write this part? How do I solve this is S9. Now on your calculator mode, this is already S, right? So on the calculator mode, don't do 1/3, just do work on this one. So go for S9. So go to second quit, get a new screen, and then you get a screen and click on alpha trace, then enter. So when you do that, what will pop up is your y1 will pop up. So your y1 will pop up, then click this one, you want at 9, then close it, then subtract because there's a minus, then again alpha trace, but this time it is go to, there will be option y1, y2, click on y2 and do the same thing, put 6, then you get some answer here. And then that answer is going to be 904.5, and then divide by 3, you get 301.5. So average rate at which shoppers are entering is 3 shoppers per hour. So from 9 to 6, 6 to 9, the average rate at which shoppers are entering is that part. Okay, so let's see this completes turn the page. It's asking us okay, let me clean this, all this part. We're almost there, ending. So you are given at what, the rate at which shoppers are leaving is given by this third one, which is given to you as L of t. L stands for leaving, right? So that's why. So he's asking us at the end of 12 hours, so 0, 1, 12 hours, how many shoppers are in the store. So that will be like, this is like how many are in the store is S. So S12 is how many are inside, and then from here you take away how many are going outside, but the going outside is given by rate, at what rate they are leaving. So you have to take integral from 0 to 12 of y3 or LT here. Okay, so LT, because remember when you take an integral